Okay, I got two ideas here I want to talk about. Zero exponents, the first one right here, and then negative exponents. How do we deal with those? So first, let's just fill this in. Any non-zero number to the 0 power is equal to, guess what? 1. Yeah. So anything to the 0 power is 1 except for 0. That's a weird one. 0 to the 0 power, we're not sure about that one. So anything to that is 1. Okay? So 0 to the 0 power is this thing of undefinedness. That's what I was talking about, it being weird. So I got my numbers down here. 4 to the 0 power is 1. 5 to the 0 power is 1. Pi to the 0 power is 1. 1 trillion to the 0 power is 1. Okay? Anything to the 0 power is 1 when a is not equal to 0. Okay? Now, the negative exponents here for any integer n and any number a not equal to 0, a to the negative n, okay? Let's say this again. For any integer n, okay, so this is your integer like a number, and any number a that is not equal to 0, so a could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, any of those numbers, but it can't be 0, right, is equal to 1 divided by a to the n. Okay, so the 1 over a to the n, which is pretty much here. It's pretty much saying a to the negative n is equal to 1 over a to the positive n, where a is not equal to 0. So here's your example here. We got 4 to the negative 2 is equal to 1 over 4 to the second power. So pretty much you just take this and you move it to the denominator, and it will make it a positive exponent. You could actually swap it to go the other way and make it a positive exponent on the numerator if this was a negative on the denominator. Now I'm going to show you why this works through a pattern. This pattern is pretty cool. Check this out. So let's say I have 2 to the third power. 2 to the third power is 8, right? Okay, so we got 8. And then let's do 2 to the second power. That's equal to 4. And 2 to the first power, that's equal to 2. Anything is to the first power. Now what I'm going to ask you this is, what is happening from 8 to 4? How do we get from 8 to 4? What do we have to do? Well, if you notice, from 8 to 4 and then 4 to 2, each time we have to divide by 2. Okay? See how we're taking a factor of 2 out? And when you're taking a factor of 2 out, you're dividing it by 2. So with that in mind, what is 2 to the 0 power? Well, we might not know. You do know because I told you right here. But how did we get to the 1? Well, what is 2 divided by 2? Well, 2 divided by 2 is 1. So that's how you can use this kind of idea of this pattern to find out that anything to the 0 power is 1. And let's keep on going. So we got 3, 2, 1, 0. Well, the next one would be negative 1. So if we had negative 1 and we divided by 2, we would have 1 over 2. To the 1 power, right? We could put it up there. See the negative 1 right here becomes a positive 1 and comes in the denominator. And if we make this 2 to the negative 2, we're dividing it by 2 again. Divide by 2. So we have 1 over 2 times 2, which is 1 over 2 to the second power. Right? Isn't that good? So, you see how negative 2 and now it's positive 2. So, using this pattern, you can kind of see how this came about. How 4 to the negative 2 is 1 over 4 to the second power, and how 4 to the 0 is actually equal to 1. Or how any number to the 0 power is actually equal to 1.